Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to talk about hydroponics. So let's dive right into it. So what the heck it is? Basically, in simplest term, it's farming without the soil. Now you might be like, what the hell? Well, yeah, soil is not needed for plant itself. Most of the plant matter you see, like the weight of the plant generally comes from atmosphere, basically carbon from carbon dioxide and hydrogen from basically water. And then some small elements, trace elements, basically micronutrients from the quote unquote fertilizer that you put in it. That's why plant is mostly hydrocarbon, basically hydrogen plus carbon. So soil, the primary role of soil in normal farming is basically it's a growth medium. Basically it helps a plant to do something. Basically it says like, okay, that is up, that is down, this is water, that is air. So basically soil is like a kind of a fundamental foundation. It helps plant to do what it's supposed to do. So what we do is basically remove soil. We bypass soil's ability to transmit basically nutrition and water and all that using nutrition solution, basically water plus fertilizer that you need, and then we get complete control. Every aspect of the plant cycle can be controlled by this. So okay, that's just the idea. So what's the science behind it? Science is basically realization, because this is a very old technology. As early as 1600 people started to realize this, that soil is just a support material. Basically you don't need, quote unquote, need soil. So and if you are familiar with gardening and farming, you must be familiar with if soil is compacted, nothing can grow into it. So because roots of most plants need some amount of either nitrogen or oxygen or flat out air. Basically it does need some access to air. Now hydroponics utilizes that concept that roots need basically some amount of air, not completely. It's not like it has to breathe air 24/7, but it does need some access to it. Then whatever substrate that we use, wherever we are growing it, basically the wool or sometimes plastic wool is used, sometimes coconut husk is used, whatever we use, we have to find out something that is inert. And in some places, people in early days, basically they used to use pebbles, because pebble will not react with the water plus nutrition solution. Now this is the critical aspect, because you are tailoring everything that goes to the plant. You must make sure the substrate wherever the plant is growing, it is not affecting it. Basically if let's say it's a unbaked soil, baked soil becomes inert, but if it's unbaked soil, it will change the pH level, it will change the basically total dissolved solid counts and all that. So we have to make sure the substrate, whatever you use, it may be plastic, it may be coconut, it may be basically whatever have you, but it must be inert. Otherwise the water plus nutrition solution will not work. So you have to make sure of that. And the fact that the root needs air, so you don't want to flood it. You will never be like, okay, let's just flood it till here. You will always give some room for air circulation. Or sometimes people do what we do in basically fishing industry. Basically you have an aerator that is putting air, basically dissolved air into the water itself if you want to flood the system. So that's the science behind it. It's 100% tested for more than 2 centuries. We know this works. This is completely known science. So how does this actually work in real life? Basically, you have to think of it this way. There is 2 primary steps into this. First, seed to germination. Basically, you can't just take a seed and put it in a growth medium and expect water to do, because we have to make sure the water level touches it. It will either flood the seed or it will simply not work. So we create a secondary stage. Basically, this is the primary function of the growth stage. Basically, you put something in a very moist environment. Basically, just moist enough. Depending on your whatever crop you are growing, it will be controlled with that. And this will help seed to germinate, basically seed from going 0 to 10. Once depending on your structure, depending on your farm, they will have a very certain rule. Basically once the root has grown to 1 inch or whatever the rule may be, then they will supplant into the actual farm. Here it will complete the cycle. So there is 2 main steps: seed to saplings, sapling to actual plant, to actual product that will be done in the farm. So these are the 2 primary stages. Then we must do very close control on the water, because there is no soil, there is no buffer. We must control the water. And when I say control, I don't mean just okay water flow and all that. You have to make sure of that. Then you also have to make sure what is the pH level of water, because this is one thing that we learned the hard way, and this is the reason why adoption of this technology is not as easy as you would think. Is think of it this way: you put nitrogen in water and it's like, okay, plants are absorbing it. Here's the deal: the moment you put something, let's say some salt that is giving nitrogen, the moment a plant absorbs it, it changes the pH level, so that water becomes toxic that water ends up killing everything down the line, because once the plant have absorbed it, they change the pH and the water become toxic. So there has to be serious quality control with water, and you have to do it in everywhere. Basically, you can't be like, okay, from tank A to tank B, you could kill the plants that are further in. You have to test it everywhere, or you have to design it in such a way that you can recirculate the water through test filters again and again. So you have to do very close control, and monitoring of nutrition is also very critical. And these things makes it kind of tricky situation. It's not very simple. It's not like, okay, put something on the ground and it will grow. It's very different. It's very difficult, because this stage alone is very tricky, frustrating to deal with. Now, right now there are machines that can do this, but this is still delicate stage. Then you put into this, and then you have to make sure you don't contaminate it with this. And water management is really tricky with this. So are there any consequences of doing these fancy things without the soil? Well, yes, first is very expensive. It's ludicrously expensive, bare minimum 3 to 8 times more expensive than anything. And it's complex also. That means most of the farmers can't touch this. You have to have someone with a proper botany degree and all that to do it properly well. Because if you have something that is good enough, of course your plant will grow. Of course they will test all right, but you want to test just right. Let's say you are making potatoes for Lay's, or tomato for whatever ketchup company you have. They will give you a specific taste. Give me this exact taste in the tomato. If you don't, they will reduce the price per ton. So to have that gives the complexity, that you have to maintain it very thoroughly. So you have to be like, okay, this breed of tomato, this needs this much potassium, I'll make sure that much potassium is there. So, and it's also not suitable for everything. Even if, let's say, you have the money, even if you have more than enough graduates to take care of it, it's not suitable for every kind of crop. Basically, generally people don't even try to, like, physics is not stopping, we just don't have the mechanics to do it. Is that you can't utilize this on sugarcane or utilize this on rice or wheat. It can be done, it's just engineering is not there. So flat out it's not suitable for those things. And the fluid management, sometimes people want to do is like, they have one greenhouse and they want multiple crops into this. It's like, okay, I want one crop, this crop or that crop. Can it be done? Yes, but again, your water management becomes another issue, because other different plants will absorb different nutrition. That will cause different changes into pH level. That will have completely drastic effect. You can have a scenario where it's like little bit of pH going down may destroy another plant. So that time fluid management becomes ludicrously complex. And this is the main aspect of soil. Soil acts as a foundation, but it also acts as a buffer. Now that simply means if you sprayed, let's say, some fertilizer, the one tree accepted the fertilizer. It's like, okay, I eat it. But here's the deal. If somebody is not eating it, it's there, it stays there. So that's why soil acts as a buffer. Here there is no buffer. You make one mistake, let's say for one time you flooded a system with too much nitrogen, it kills everything. One time you killed like you made a mistake of putting too much potassium or too little, yeah, it kills everything. There is no tolerance for failure. You make a mistake, you did, basically your crops goes down. So these are the consequences of this system. Then why I'm talking about it? Well, the benefits of this is ludicrously high. First, this is the best option for leafy vegetables, basically from lettuce to tomato. Like tomato became an industry. At this point in time, there are greenhouses that are making tomatoes in a 100-ton kind of batches. So understand this, like this has become a big industry. Many of tomato ketchup company started to create their own greenhouse for this, because they get such a precise control, and the fact they can do this year round, it has become a booming industry. And because this saves water. Now you're like, how the heck it's saving water when you are doing everything in liquid? Yes, the liquid does not evaporate like, you know, when it's a large pool status. Basically, if you're spraying water, it will evaporate much quickly. If you have a, like a, let's say, glass of water or bottle of water, it will take time to evaporate. So it's not like evaporation loss does not happen in this. It's just very little, because root is always submerged in the water. It will absorb whatever it needs to absorb, and if it's not absorbing it, it's not going to evaporate. It will just flow away. So evaporation happens very, very slowly. So in terms of when I'm talking about in my last video about drip irrigation, I was talking about like it saves 10 to 25% of water. This can go as high as 90% water saved. Like for there is a metric for, like, let's say 100 ton of tomato, you have to spend this many gallons of water. This will be like, can cut it as, like, you know, as much as 90% out of that. So that's a very big incentive right there. That's a very big incentive, and that incentive becomes bigger and bigger because water scarcity is happening. On top of that, it requires very little fertilizer. Now you have to do so much management. That's the whole benefit of it. Whenever we are giving fertilizer to land, we don't know exact amount, so we just, like, you know, flood it. It's like just better to be on the safe side than to be, like, you know, under fertilize something. Here, because you are getting constant feedback, you only have to give just the right amount. If it's like it only needs 10 milligram, you will give 10 milligram. try to distribute 10 milligram like let's say to 100 plants in a basically farm. It just cannot be done. Here you can do it because water is a system that you can pass it through multiple detergents. Like okay, phosphorus is going down, let's add a little bit of okay, enough. So that's why fertilizer need also goes down drastically. Like it's not a joke, like it will save you a lot of money. On top of that, you don't need pesticide because there won't be any weeds and all that, and because weeds and all that, they act as a like a biodiversity enhancer, and a lot of insects and all that start coming in, and then you need to pesticides. Here, because this is quote unquote sterile environment, nothing happens. No pesticides. That's a very big basically selling point. At this point in time, this is such a big selling point that places like New York, people are creating indoor basically lettuce growing environment or whatever have you, and they're selling the produce, but it's not cost effective, it's very expensive, but they're selling it simply by pesticide free, and it's legally pesticide free. It's 100% pesticide free. So that also plays a very critical role. So when you're talking about industrial scale and you're not doing indoor farming, then the fact that you will save water, that's a tremendous deal. The fact that you will need much less fertilizer than compared to open soil, much more awesome. No pesticides, really awesome. Then the fact all these things are like, that's the first yield of crop. The second is that it will give you much higher yield. Basically, let's say once somebody gives you, okay, this is 1 hectare of land, do whatever you will. If you grow based on open soil, you have a certain limit, but when you are talking about hydroponics, you can go vertical. So in vertical scenario, you can exceed it by minimum of 3 to 10 times per hectare. So you don't even need giant hectares of field, especially for leafy and tomatoes and all that. Like in a small greenhouse, you can grow as much as for a small town. You can be like, okay, this town, like I got this. That's the benefit of that. On top of that, it's also quick, because you have to understand, plant generally when you plant them in the soil, they are fighting multiple things, basically from temperature to all that. Here you are taking care of that. So benefit of that is plant grows very quickly, because plants' roots are designed to like basically jam their way into the soil. They are like, you know, they push the soil away. That takes energy. Here they don't have to do that, because it's just going in there, and because it's such a well controlled environment, perfectly tailored for the plant grows very quickly. So let's say a crop that takes, let's say 60 days, you can grow it in like 55 days, or sometimes even half that. Now you might be like, that's not a big deal. It's not a big deal in first year, but imagine if you are doing it like let's say tomato all year around, that will be translating into like, let's say in 3 years you will have like 4 year worth of crop growth. In 5 years, you can understand this starts to pile up. So the fact that you are growing a lot more per area of land, because land is very expensive, that itself saves you a lot of money. Then the yield is also quicker. And some places people are like growing in 60 days. They're like, okay, from seed to final product in 60 days. That's awesome. So this is the reason why people are considering this the future of farming. To give you a real world concept of this, think of this way. Malaysia specifically suffers from lack of adequate amount of land. So, and people want to have a rich taste, basically they want salads and all that. So those are generally leafy things, but they realized if they started basically growing this on a rice field and all, the rice price will go up, and people need rice. So they started creating hydroponics garden on top of buildings and some abandoned places and all that, and they started to reduce the price of these things. They were like, why, how the heck that's even possible, even though this is expensive? Think of this way, from Malaysia's point of view, they had to import everything. So that import duty, the import charge, the import pipeline, all of them added up so much cost that even though, let's say, growing it properly in proper places, in proper farm, it would be like, let's say, $1 per ton. Here, by the time it reached to Malaysia, it was like $20 per ton. Growing in a hydroponics lab, where they are indoor lighting, they want to generally control too much, so they want to do indoor lighting. They were getting like instead of $15, they were getting like $10. Still more expensive than open source scenario, but because you have to import everything, it was very, very profitable. So at this point in time, many corporations have already moved, specifically tomato ketchups. They are like, yeah, this is the way to go, and leafy vegetables are already starting to catch on. So now, will this replace everything? Hell no. I told you, specifically rice and wheat, they will take specific amount of time, because it's not a problem of can we do this or not, it's the problem of engineering. In this, the engineering has been solved. So at this point in time, this is the way to go in the future. Basically, if you have to feed New York, you can utilize this. How? Basically, you can grow it on the spot. Let's say if you have New York and you want to like take care of all the leafy things that New York has, the Central Park is more than enough. Heck, one tall building you can grow using rather than sunlight, you can grow using red light. I'll make a dedicated video about that next time. But there you can grow a large amount of crops in a very small place and with very high control, quality control, where you don't have to worry about pesticide, fertilizer and water. So that's a very amazing thing. The fact that you can of course, you will still need your big farms that are producing the bulk load, but all these leafy produce that people want to be clean, healthy, and all that, they can enjoy this also. And this is really good for environment also, because you have to understand, farming is inherently destructive to the land. Like, no matter what you do, that's why you don't hear, oh, forest of wheat or forest of sugarcane. There never will be. Like, inherently, crops are not crops are man-made. So yeah, we made it 50,000 years ago, but again, crops are inherently man-made, so they consume little bit from the soil every time you do it. And that's why we have to do precision farming for that. Like, okay, it's consumed phosphorus now, okay, let's add phosphorus. It consumed nitrates, let's add nitrates. So that way you have to understand, inherently destroying the land where you are placing it. Now, of course, if you have good engineering, good management, and good skills, you can stretch that for like 1,000 years, but over time it will get salty. That's why people say, salting the earth, over time it will become useless. Now in this, because everything is isolated from the ground, and you have a water which you can recycle as many times as you want. So there are a lot of pros into this. Yes, it is complex. Yes, it's expensive. Yes, it requires someone with serious intelligence to do it correctly and make profit out of it. But it is the future, inherently, flat out. So this was my presentation on hydroponics. I hope you liked it, learned from it. In that case, please leave a like button. And if you didn't like it, I would urge you to press dislike. Please dislike it twice to show me your extra disappointment. And I would urge you to leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.